Okay, hello students. Here I'm walking through practice problem, lesson number u- unit 5, Algebra 2, lesson number 5, and the main goal is to understand what is the meaning. The concept is about the even and the odd functions. So how do we know something is an even function? Is here it is f of x is f of minus x. For the opposite input, the output is the same, or in other words, when you reflect over the y-axis, the graph matches. So that's even function. And then what is the meaning of this part is odd function. So you will see that what does this means is not just the opposite of the input and also the opposite of the output. So as I walk through the problem, you will understand more better. So let me go straight away. Here's the even function definition, and you can clearly see this graph is, if you reflect over the y-axis, this dot which you see is exactly matches this dot. So the output is the same, the y coordinate is the same. The distance of the point from the x-axis of both the points on the graph is the same for the x and the negative x. And that's why this is the even function, because when you reflect over the y-axis, the graph, you get back the same graph. But the difference between this one is, look at this graph. In this graph, you will see the point basically is reflects. Imagine this is the point which is down at the bottom. Now this point is reflects over the origin, and you get back that one. Just to understand this, let me take this graph. So two ways you can say whether it is an odd function. How do you know the function is odd? Is two ways. Either you say, okay, reflect over the point, and the point is the origin in this case. Origin. So that means any point, this point, you can see that this, whatever from the origin, if I do a directed line segment, and the opposite is on the other side, so they exactly match. And then what that means is, if this is 2 and imagine if this point is 2 and negative 5, then the other side, this point is the opposite of plus 2, which will be minus 2, and the height is 5, so this is going to be minus 2 and positive 5. So this one. So what it means is, basically, if x and y is a point of the graph, then also the opposite of the input and the opposite of the output also. This also is a point. In this example that I showed is, if it is plus 2 and negative 5 is a point on the graph, then also minus 2 and minus of minus 5 is plus 5 is also. So if this is the point on the graph, then this also is on the graph. That's one way to look at it, or you can also look at it like reflecting over the x-axis and over the y-axis. So two ways. So one is, okay, let's first reflect over y-axis. Now what that means is, you get something new, which is f of opposite of the whatever that point is. I do the opposite. So that's the first part. That means this graph will get, this point will go on the other side. This will go somewhere here. This point which is right here will go. So reflect on the other side, and you will see it will go. Now this point will be somewhere here. This point will be somewhere here, and then you will see the graph. The new graph will be this way. See, first it will go like this. This is the reflection over the y-axis, and then you have to reflect this whole thing, the new one. So this gx, I'm going to call the new one will be g of x, which is you reflect over the y-axis, x-axis. It means it's minus of this part, which is f of minus x. So the whole thing, this pink color, this go back over here and it reflects, and you get the red graph like this. So that's why two ways. One is reflect over the origin, can be one way of to say that it is an odd function, because you get back the same thing, or you do two parts. One is you reflect over the y-axis, and then also you reflect over this means you reflect over the x-axis. So 2 ways. So that's odd function. Let's go directly to solve the problems. So this is question number, this is practice problem. So I'm working on practice problem. Check your packet that you have. It should say lesson number 5 and should say practice problem. Okay, the first problem is right now question number 1. There are 4 graphs. So I'm showing you 2 graphs right now, and the question is this even function, or is it odd, or neither? So this is what we are supposed to. By just looking at it, I think the first one, so the black graph that you see right now here. So this graph that you see, clearly if you reflect this graph on the black graph, any point on this point, if you reflect over the y, I want to know whether it's an even function. For the even function is, by just looking at it, you know that this point goes on the other side. See this point? So this is a reflection of this point. This stays the same. Let's take any point here, which is maybe 5 and 4. This is 5. Oh, sorry. This point is 5 and 4. So if you reflect this, so if you reflect the whole black graph, you get back this whole thing again. See this dot will go here, so that's how it is. Any point here will go this side, so, and when you reflect, you get back the same thing. In other words, what does it mean is, if there is a point here, this point is, let's say, 3 and minus 9. So this is 3 minus 9. On the other side, it is minus 3. So minus 3 is minus 9. So you have that. It's like, if you have xy, and then you also have minus xy. So the opposite input output is the same. That's it. So you can say, yes, this is even function. But the second one, what about here? Do you think, let's just imagine, if I want to reflect this, this will go on the other side as this way. See? So you don't get the same graph again. So that's why this is not even. This is not going to be even. So this is not even function. But the question is it a odd function? How do you know this is odd function? One way to look at it. So the new graph, maybe whatever that you want to have, is it really a negative of minus x? So this is like confusing kind of stuff here. What it means is, it is minus of this part, right? This means you reflect over y-axis, and when you do minus of that means this is reflect over x-axis, and if you get back the same original graph, and you're done. Like in this example, watch this. First step is you reflect this graph. Okay, I'll just take only this much on the other. So it will go this way. This graph will reflect over the y-axis, and you get this. See, this is the one. And after that, so this black graph that you see, I reflected on the other side, and then again you reflect this graph, okay, and over the x-axis. So this point will go up, okay, and maybe this point stays, this point will go down. So this whole thing, this graph will go here back again, and you go this way. See? There you go. So basically what it means, if you reflect twice, you get back the same thing. So this is an even function. Done. Okay, if you see this question number, this is this C part. Look at this graph. It looks like, if you see this graph which you see here, this one is reflect over the point. It reflects here. This part is fine, right? And that's because you may say how, and you can easily see, if this is the original graph, the reflection will be something like this on over the y-axis. This is how this will be this, and then after that you can reflect over the x-axis, and you get back the same thing. See, so this is reflection over the point. Any point here is okay, fine. This point is same on the other side, so reflects this point. So that is takes care. What about the other one? We need to also check what happens to the black graph that you see right here. So this is black graph. So this part I want to reflect and say, do you think it is really reflection? And by just looking at it, you can see. Okay, let's take a point. I want you to take a point here. Why don't I take a point? Let's see, this is the point. Okay, if I take this point, it's like 1 1, right? So if 1 1 is there, then remember to have an odd function. The input should change and also the output should change. So this also should be part of the, but the minus 1 is right here. So the reflection of this point is here. See, so this point is reflected over this, and you get here. So this point is not the part of the graph, not part of graph. So that's why you see, if you reflect over the origin, you don't get the same graph. So you say, okay, that's not neither even. So this part is so not even and not odd also. So that's hard, neither even nor odd. Or you can also use in your notebook, on your paper, you can say, okay, let this graph, let me first reflect over the, so y-axis. So this will go something like this. So this will go this way, and then it will go down, right? To this part. This first you reflect like this way, and then you want to reflect over the, let me use red color. Now I want to reflect this over the, so this point is over the y-axis, sorry, x-axis. So I've done over the y-axis, now I need to do over the x-axis. So if this is the one, this will go something like this, okay, and this will go something like this. So this will be the graph of the blue, reflection of the blue graph will be the red graph, and that does not match your original graph there. And you can clearly see why I'm saying it. Let me clean the other part, and see this part. It doesn't match the black one. So neither. What about this one? See, this is the easy one. So if I say this is the blue color, now if you see, this is actually it's like a graph, cube root of x, maybe fifth root of x. You can check. So this is the graph, and if you pick a point anywhere, if you pick a point, let's imagine if I take a point 4 and I don't know what is this, maybe 4 and 1.5. On the other side there will be -4 and minus 0.5. So this point is -4 and -1.5. So they reflect. This reflect. That's how it is. So this is reflects. See the red color. This point reflects over this, and that's why this is a even function. And you can always check with the help of. So you can also do in another way. Is okay. Let me first reflect over the y-axis. So this will go something like this. See? So this will go like this. This first you reflect, and then you reflect over the x-axis. And when you do this, the blue graph will go reflect this way, and it exactly matches the red one, and you're done. so the new graph will be maybe hx is equals minus of f d of minus x. In this case, it is dx. So now you know that's that's the odd function. Okay, in the second problem, if you see the table shows the values are, now this is it's being given to us that f is even. It means f of minus x is same as f of x. It means with the opposite. So these are called opposite input. So opposite input means the output is the same. The y's is the same. So let's take simple example. One of them is given. Look at this. If this is given negative, now this has to exactly match. They are the opposite. This is plus. So this output 8 has to be 8. Then let's check this part. 1 is minus 1, and here the question is what goes over there, y coordinate. These are the y coordinate. So 1 is minus 1, and this is plus 1. The other one is minus 1. So this has to be the same here, right here. So hope that helps. So let's see the next one then. And one more is, this is negative 4 and 2. This goes exactly like that. So 4 and this is plus 4. They have the same opposite input. So output has to be same, which is, if this is plus 2, the other one is minus 2, and you're done. What about this one? This is 3, 0, this 2. They are the opposite. This is the y coordinate over here. So this also has to be. And you are done. That's how you fill the graph. Let's see the next question, the problem. So question number 3, here is the graph. So you see the graph right there, and there is a y equals x minus 2, which is means it is the slope is 1x, and the y-intercept is, so that's the y-intercept where it goes to minus 2. The slope is 1 over 1. You can see that. The question is there a vertical translation? Now what is vertical translation? Means if you have a graph, let's say this is a graph, vertical translation means you want to maybe move it 3 places up. That's called vertical translation. So they are asking, is there something like this where if you do that of the graph, that is the line that represents an even function. So no matter where you take this graph, let's say if I want to take this graph, let me take it two steps up, 2 unit up. So this will be a line parallel through the origin. But if you so is this going to be the, if this is f of x and let's say this is g of x, the question is gx, or if you reflect, do you get back the same thing? Is the same thing as gx is gx is same as f of minus x? That's the question. So maybe one thing is first of all, gx is you push it up. That means you take it up. The original one is f of x, and you take it up. But the new one, is it going to be a even? Let's see, if we want to reflect on the y-axis, this line will go like this. So it will never match the gx function here. See, this is the new one, but if you reflect, it goes this way. One of them has a slope which is positive, the other one has a slope which is negative, so they never match. So this is not possible. If that's not possible, what about the second question? In the second question, they are asking whether is there a vertical translation that it gives you makes it an odd function. So the same thing, this time I'm going to take it 2 places up. So let me draw. So this is the line. So the first step is I create a function gx, which is f of x and plus 2. There you go. So you push this up, translate 2 units up, and then the question is, if I reflect this 2 times, so now listen to the words that I say. If I reflect over y-axis, then reflect over x, do you get back the same thing? That's the question. So the blue color, let's reflect over the y-axis. So this will go this way, right? You get like this. Then after that, you reflect over the x-axis. So if I reflect over this point will go down somewhere here. This point will go up. So you get back. So this red line, first the blue line becomes the red line, and after that the red line becomes the red line. When you reflect over the x-axis, it coincides with the original, the blue one, and the blue one is the gx. So you get back the gx. So that means the new function. So why you say this is because, So the new function gx, the one that we translated, so you translate your 2 units up, you get new function. This is the one that is gx, which is f of x plus 2. This function is odd function. Now you may want to tempt it to, you can also plug in. Now remember, this is f of x. Let's plug it here. It is x minus 2n plus 2. What you get is that gx is x. So it's a line. What does this? It means it's the line y equals x. It means it is 1 times x plus 0. It means it is the line. It is the line through the origin and with the slope 1. That's it. So this line is always odd because you can reflect over the y-axis and then over the x-axis, and you get back the same thing, and that's why it is a odd function. Hope that helps. Let's go to the next. This one they already just wanted to let you. I want you to pause this video for a while, and if you can figure it out, what they are saying is the function is already odd. That means whatever that something is already odd function. I'll take an example. Maybe this one. So let me draw a cubic function. So this is like a cubic function. So this is cubic function. Okay, let me draw. This is like y equals x cubed. That's odd function. Okay, and you can see that whenever there's a odd like this, it could be x raised to. We've seen the earlier one, y equals x raised to 1. It could be y x raised to 5. It could be y x raised to 7. And in this kind of thing, you'll always see that if I put minus of f of minus x is same as, you get back the same thing. That's what that means. But now question is, what are the things that can happen? Whenever there's an odd function, the good thing is you should know that if there is a 2, this graph doesn't look like a cubic function. Let me make a real cubic function then. So let's see, this is like a cubic function. Still not good. Like that. So if there is a 2, if I call this is the function, if there is a 2 here and there is a 8 here, this is like 2 and 8, right? So this part is like 8, because 2 times 2 times 2, if I plug in here 2 raised to 3 is 8. So the point 2 and 8 is a point on the graph. Okay, so if that's the case, for if it is odd, like look at this one, there is a minus 2 here with the opposite input, and the output is minus 8. So there has to be a point right here which is minus 2 and minus 8. So in other words, there is a reflection of this point gets reflected over the origin here. It goes right here. So that's all. Not only you change the, you don't only change the input. So plus 2 is minus 2 and plus 8 is minus 8. So the first part is, look at this. If f of 5 is 2, then f of minus 5 is 2. The output are the same. The input is opposite. That's actually for the even function. So this doesn't apply. This is wrong. Okay, f of 5 is 3. That means 5, when the input is 5, the output is 3. What does this mean? When the input is negative 5, output. And you can see both change. This plus become minus, this plus become minus. And that is correct. An odd function is always a reflection over the y-axis and takes the graph to it. Do you think this is when it is even? It means if there is a graph like this, then it is like this. That's even. That this doesn't help. What about the next one? Reflecting f both x's. Now what is the meaning is you do over reflect over y and then reflect over x, and then yeah, that's true. You can see this graph which I have graphed here. Let's say this is this. I think I've been doing this so this is the graph. It goes. So first you reflect over the y-axis, And the same thing, this graph, you have to reflect over the x-axis. So it will exactly match this is path. It matches. So that's correct. But the last one is a little tricky there. And it says, what about f of 0? Do you think f of 0 is always true? The one that I show you, it seems to be okay, but we could have graph. I'm going to show that not always is going to be true. Let me take off this part. Watch this graph, which is a reciprocal function. What is a reciprocal function? Reciprocal function is f of x is 1 over x. And what it means is, you can't have x cannot be zeros, right? You can't have an input. If the graph is something else, this is the graph of, you can see clearly any point over here, it reflects right here. So, it reflects. So this is odd function, but then first of all, 0 is not even part of the domain. X cannot be 0. So this is not right. So that's wrong, and you're done. Okay, there are 3 problems for question number this. Let me do one at a time, and I hope that helps. The first thing is, remember, if I have n radical index and it is b, the definition is b raised to 1 over n. So this has to be known. If you forget this, then we are lost. So this thing I can write as 1 over 4 times, and now you can apply the same thing. Instead of n, you have a 3 here. So the b is d, so I'm going d is 1 over 3 equals 15. Question is, we need to exact solution, right? So now what you do is, you need to isolate. I want to isolate d. What does isolate d means? You want to keep d by itself. So multiply 4 both sides. On this side, multiply 4 both the side. And this 4 goes away and you get d raised to 1/3 equals, this is 60. Now you can't have a fraction, right? So how do I, at the most what can we do is you try to cube both sides. Let me write here. So it means you have cube both sides. So what is that cube both sides means? It means you say raised to the power 3, raised to the power 3, and this 3 goes away. Why? Because it is 1 over 3 times 3 using the laws of exponentiation, which is d raised to 3 over 3, and that's like d, right? So you write d equals, and what is 60 times 60 times 60? So if I multiply 60 times 60, that's 3,600, and if you multiply another 60, you get, I think, 216, and there are 3 zeros here, so you put those 3 zeros to get the answer, and you're done. Then let's go to the second question. Now for this question, let me write it again. It is cube root. Now cube root means it is e raised to, so this is going to be e raised to 1/3 equals 7. Now there's a negative. You can't have a negative 7, so you multiply both sides by -1. So you multiply -1. So this negative makes it positive, and e raised to 1/3 is -7. And then multiply, cube both. So this is the same stuff. And this 3 goes away and you get, I think it is 307 times 7 is 49, and you multiply 7 again, 7 at 343. You can always check, but there's a minus. Remember, there's a minus sign, and there's an odd exponent. Whenever there's an odd exponent, this minus stays. It's because you have -7 times -7 times -7, and you see that this 2 -7 will be positive, but still there's going to be one of the negative will stay, and the 7 times 7 times 7 is 343. And the last one, this one is, again, I'm going to write it as f of -5 is like a b raised to 1/3, because there is a cube, right, 3, right? So that changes to 1/3. But then there is a 2 and equals 4. You subtract 2 both sides. So this goes away and you get f -5 raised to 1/3 is 2. Then you can cube both sides. So when you cube both sides, you end up cancelling this and you get f minus 5. 2 times 2 times 2 is 8, so that's like 8, and you add 5 and that goes away and you get equals to 13. You're done. So that's easy. Let's go to the next. Now this is a this is a easy question because here is the graph. You can see oh, wait a minute. Okay, if you see this graph, the question is asked, here is the graph, f is given to you, and graph the function g. So you're supposed to graph another one, g graph, and it's already shown to us, so simple. So this is just nothing but it's just a reflection over y-axis. No, nothing to do with odd and even. This is just the gx, so the new one that you're going to do. This gx is minus of f of x. It means whatever the output of gx is the opposite of whatever the output here. That means this point is right here. The output is 1, 1. It will be right here. 1 minus 1. If it is 4, 2, this will be 4 minus 2. If it is 9, 3, it will be 9 minus 3. And you get a new graph. So simple. So I don't want to waste time here. That's it. You're done. So this is the G graph. The second part is, where is the H graph? Let me do it right here. The H graph says, this part is nothing but a definition of even function or reflection over y-axis. So if this is 1, 1, the other side is minus 1, 1. If this is 4, 2, it will be minus 4, 2. If it is 9, 3, it is minus 9 and 3 right here. And you get something like that. There you go. That's it. That's all you're supposed to do. Make it nice. Use some colors to show. So this part is reflection over the y-axis. That's it. You're done. And let's go to the last question. Okay, here is the question. The graph models the Priya's heart. So that is Priya's heart rate during the run. So Priya is in a process to run. Imagine she's here and Priya is, let's see, this is Priya, and then she may be sitting at one time. So one time she's sitting and then she stand and then she start, okay, at a certain time. So what does this mean? Basically her heart rate, this shows the heart rate is about maybe 75 before she start. Little above, maybe little above. I'll put it like, okay. Then exactly at 1 hour from noon, this is 12. This is 30. That means 1 o'clock. That's where she start running, right? The moment she starts running, then her heartbeat goes up almost like 150, and then once she runs, then almost she's stopping after the running, so she stops, and then very soon her heart rate goes down to back to 2, and then she stand till like this. So that's what that means. So the question is, what was Priya's approximate heart rate before and after? So the before, the heart rate was 75, and after one also is 75. And how much was the heart rate during the run? That's very clear here. So during the run, that's the heart rate when she was running, which is almost 75. Those is 70. And the last question is, can you sketch the graph? Graph would look like if Priya went to run 3 hours later. So what does this 3 hours later basically means? Is the entire graph that you see, the black color graph, it has to be shifted 3 units to the right. So that means what this means is, let's see, if this point is like 0.5, okay, so if I add 3 hours, it becomes here. So this point will go right here. See, that's how it is. So this point. Then one more thing I want you to check also is this point at exactly 1 hour from noon. That's where she start running, right? So 1 plus 3 is, so 1 plus 3 is 5. So that means this point will be 5 here. So this point will move 1. So this 1 which you see right here, 1 plus 3 is 4, right? So that's how it is. So this goes right here. That's how it starts. Then after that it goes up this way. Okay, it goes this way, then goes this way. Everything goes the same thing. Let's see, this is at 2. 2 plus 5 is 7. Where is 7? Sorry? Sorry, it's 2 plus 3. So if this is 2 plus 3 is 5, so that's 5. So that's where it stops. And then that's it. Okay, let me use, hopefully I can show this last one this way. So this is 0.5 almost to 1 and 3.5. So this will go from 3.5 till something like this. Okay, this way I think I'll try to do. And this is like almost like little 1.5 to 150. So from here it goes this way, then goes little to the right. So that's the pulse rate, and then this is exactly at 2. 2 plus 3 is 5. So I want to make sure this is 3 and something like this. Doesn't look good. So I have to extend this one little to the right. And then from here, okay, let's just do it. A little confusing. Anyway, so that's how it is. And then it goes another one. So 2 plus 3 is 5. You're done. So I know this, it doesn't look good, but just wanted to show that this, I think this has to go like this much. You're done. So okay, that's how I wanted to say complete. So this completes problem unit 5, lesson number 5, practice problem. So next class we will see lesson 6.